When we think of nuclear radiation, images of disasters typically pop into our minds. But you may be surprised to hear that radiation, like most things, can be extremely beneficial if used properly and carefully. For example, when X-rays were discovered a century ago, they profoundly changed the practice of medicine by enabling physicians and scientists to see inside the living body. Today, the medical field is undergoing another major transformation through nuclear medicine. Nuclear medicine uses radioactive materials to help physicians diagnose and treat certain medical conditions. While other imaging techniques such as computing tomography or CT scans and magnetic resonance imaging or MRI scans show only the anatomy or structure of the organ, nuclear medicine imaging also shows the physiological functions of the tissue or organ being investigated. So, how does it work? With nuclear medicine imaging, tiny amounts of radioactive materials called radiotracers or radiopharmaceuticals are either injected into the bloodstream, inhaled, or swallowed. The radiotracers accumulate in the area that is being examined and give off radioactive emissions in the form of gamma rays. A special camera or imaging device that can read these radioactive emissions is then able to take images of the area, creating pictures and revealing molecular information that physicians can use to make a diagnosis. Nuclear medicine imaging provides unique information and offers the potential to identify diseases in their earliest stages. This type of imaging is particularly helpful for diagnosing thyroid disease, gallbladder disease, heart conditions, and cancer. It can also help diagnose Alzheimer's disease and other types of dementia and brain conditions. Nuclear medicine can also be used for the treatment of various diseases. An example is radioactive iodine therapy, which is used to treat Hodgkin's lymphoma, bone pain, hyperthyroidism, and thyroid cancer. The radioactive iodine is introduced into the body either as capsules or in liquid form. As the thyroid cells or cancer cells absorb this substance, it kills them. Nuclear medicine can also be combined with immunotherapy, which is known as radioimmunotherapy or RIT. When combined, the two types of treatments can more specifically target the cancer cells. In immunotherapy, a laboratory-produced molecule called a monoclonal antibody is engineered to recognize and bind to the surface of cancer cells. Monoclonal antibodies mimic the antibodies naturally produced by the body's immune system that attack invading foreign substances, such as bacteria and viruses. In RIT, a monoclonal antibody is paired with a radioactive material. When injected into the patient's bloodstream, the antibody travels and binds to the cancer cells, allowing a high dose of radiation to be delivered directly to the tumor. In the future, it may be possible to combine chemotherapy with nuclear medicine. In this way, the chemotherapy would kill only the target cells and not the nearby healthy tissue. This would reduce some of the adverse effects of chemotherapy. Now, you might be wondering, is it even safe to introduce radioactive materials to the body? How much radiation is received from nuclear medicine? Or, to put it simply, is nuclear medicine dangerous? While nuclear medicine tests do expose patients to radiation, which can be dangerous, the radiotracers use such small amounts of radioactive materials that the potential benefits typically far outweigh the potential risks. The amount of radiation that a patient is exposed to is similar to those of other diagnostic scans. However, a woman should always tell her doctor if she is pregnant or breastfeeding so that the doctor can determine whether or not a certain nuclear medicine test is safe for the baby. At the end of the day, no medical procedure is entirely risk-free. As we continue to learn and understand more about radiation, and as technologies develop that allow us more control over it, the breakthroughs that will be discovered will change the medical world forever.